Welcome to my class. Introduction. Class Standard 10. Subject Higher Mathematics. Chapter name Probability. Exercise 14. Lecture 1. Today's lesson. Basic concepts of probability and some elementary definition. Here follow a figure. Seeing a cloudy sky, we say rainfall is very probable today. I follow another picture. If a student is unmindful of her oblique his study, we say the probability of her or his success in the examination is very little. Now, definition of probability. Probability is the mathematical measure whether an event may occur or not. Probability is a way of expressing knowledge or belief that an event will occur or has occurred. Mathematical definition of probability. Let S be a finite sample space associated with a random experiment and A be an event of S if the total number of sample points of A be number of A, that of S be number of S, then the probability of the event A is denoted by probability of A equal to total number of sample points in A divided by total number of sample points in S. This is equal to number of A divided by number of S. For example, if a dice is cast, then the sample space S is equal to 1, 2, 3, 4, 5, 6 and an event of an odd numbers is 1, 3, 5. So number of S is equal to 6 as here is 1, 2, 3, 4, 5, 6 and number of A equal to 3. That's as here the element of A 1, 2, 3. So number of A equal to 3. Clear? Therefore, probability of A is probability of A equal to number of A divided by number of S. This is equal to 3 by 6. This is equal to 1 by 2. Clear? Remark. Probability of an event A is represented by a real number in the range from 0 to 1. That is 0 less than or equal to probability of A less than or equal to 1. Clear? Now basic concepts related to probability. Random experiment. A random experiment is where you know all possible outcomes of the experiment, but you cannot say the exact outcome of a certain attempt in this experiment. For example, we know all the outcomes of throwing a dice, but we can not exactly tell which outcome will occur before throwing the dice. So the experiment of throwing a dice is a random experiment. Clear? That's mean a dice has 6 sides, 1, 2, 3, 4, 5, 6, and all the sides are known, but when you throw a dice, the result will be what? We don't know. So the experiment of throwing a dice is a random experiment. Next, event, an outcome or a combination of outcomes of an experiment is called an event. For example, getting 3 after throwing a dice is an event. Again, getting an even number in this regard is also an event. Equally likely events. If the possibilities of the outcomes of a random experiment occurring are same, which means no outcome is more or less likely to happen than any other outcome. The possible outcomes are called equally likely events. For example, the occurrence of a head or a tail in the tossing of a coin are equally likely events, unless the coin is defective or biased in some way. Therefore, getting head and tail are equally likely events. Clear? Mutually exclusive events. 2 or more possible outcomes of a random experiment are called mutually exclusive event if the occurrence of one of those events precludes the possibility of the other events. For example, in the tossing of a coin, the occurrence of head and a tail are mutually exclusive events, since if head occurs, then tail cannot occur, and vice versa. That means head and tail cannot occur at the same time. Favorable outcomes. The outcome of interest of an event is in an experiment is called favorable outcome. The number of favorable outcomes of getting an odd number on throwing a dice is 3. Sample space and sample point. The set of all possible outcomes of a random experiment is called the sample space. The tossing a coin has 2 possible outcomes, head and tail. If the result of this experiment is expressed as S, we can write S is equal to HT. This is a sample space. So in this case, the sample space is S is equal to HT. Suppose 2 coins are tossed simultaneously, then the sample space is HH, HT, TH and TT. Every event of a sample space is called a sample point. For example, HH is a sample point, HT is a sample point, TH is a sample point, TT is a sample point. Clear? The experiment of throwing a dice once has the sample space S, HT, and here S of HT is a sample point. Clear? Sure events or certain events. An event is called a sure event when it always happens. The probability of a sure event is 1. As for example, the probability that the sun will rise tomorrow from the east is 1, or the probability of not seeing the sun in the night is also 1. Not seeing, okay, but seeing is 0. Impossible event. An event is called an impossible event when it never occurs. The probability of an impossible event is 0. As for example, the probability that the sun will rise tomorrow from the west is 0, or the probability of seeing the sun in the night is also 0. Clear? Method of probability tree. Using the method of probability tree, all possible outcomes of tossing two coins together may be exhibited in the form of a diagram as follows. First coin after tossing will get either head or tail. Okay. First coin head, but second coin will be head or tail, or first coin tail, second coin will be head or tail. Therefore, sample point HH, HT, TH, TT, and together this is the sample space, but each of them is sample point. HH is a sample point, HT is a sample point, TH is a sample point, TT is a sample point, but together total is a sample space. Clear? So the sample points are HH, HT, TH, TT, and the sample space will be HH, HT, TH, TT. Now follow the problem. Suppose two unbiased coin is tossed together. Form the sample space using a probability tree and find the probability of getting head on first coin and tail on second coin. Same, we have to draw this tree diagram using the method of probability tree. All possible outcomes of tossing two coins together may be exhibited in the form of a diagram as follows. I have explained a few minutes ago. Okay. So the sample points are HH, HT, TH, TT, and the sample space will be HH, HT, TH, TT. Here the number of sample points is 4 and the favorable outcomes is 1, that is HT, because head of first coin and tail of second coin. Head of first coin this and tail of second coin this. Okay, only one condition. Therefore, the probability will be 1 by 4. That's means favorable outcome 1 and total outcomes 4. This is the required answer. Okay. Assessment. Problem 1. Suppose an unbiased coin is tossed thrice. Okay. Show the sample space using a probability tree and find the probabilities of the each of the following events. 1 number, getting just one tail. 2 number, getting head in all 3 tossing. 3 number, getting at least one tail. Okay, so everybody will solve this. Now homework. Make an assignment on the lecture and submit the copy in the group. Date of submit 15/7/2020, time 9 p.m. Okay, today up to this. Thank you everybody. Goodbye.